Right, the next phase, next part of this topic is going to be looking at how the magnetic field lines are actually moving in a certain direction. And one of the questions that you could be asked is that how do you determine in which direction the magnetic field lines are moving in? And the answer for that is going to be plotting compasses. What you do is that in an experiment, you actually put a plotting compass, a circular plotting compass here. And what would happen is if you put a series of plotting compasses along the magnetic field lines, you will notice that the needle in the plotting compass will actually follow in this direction. So you can see that the plotting compass will actually show that the needle is pointing from the north, and it will be gradually be moving towards the south, and that is exactly what you actually get. And again, obviously where the magnetic field is strongest, okay, obviously will be on the ends of the poles here. Now if we now move on from this, and we can see from here that when you bring the two bar magnets together, this is purely a recap from obviously what we talked about earlier on, where we have two north and north poles basically are going to repel, and obviously two south and south poles will also repel as well. So what we say is that the like poles, i.e. the poles that are going to be the same, exactly the same, north and north, south and south, will repel. Like poles repel, unlike poles, i.e. north and south, attract. So I'll say that again, like poles repel, unlike poles attract. Now we can now talk about basically looking at this section here. Now this type of question will basically focus on looking at ion filings again. Now it's important really to understand now what happens basically when the ion filings are actually showing this interaction process here. And you can see from here that if you go back one step slightly, and you can see from this section here, now these magnetic field lines are actually moving in a circular pattern around and back towards the south again. And similarly, you can see the lines actually moving in a closed path, in a sort of like curved path from north to south as well. Now we can see again from the ion filings that when you bring two north and north poles together, the ion filing is actually almost pushing away, showing that there's going to be a repulsive force between the two like poles. Now again, obviously for north and south, this is going to be slightly different, and from here you will actually see the ion filings actually producing a pattern going from north to south, and this can be seen by this picture here. So where the field lines are actually going to be shown by the ion filings going from north to south. Again, it's a curved path, you can see from here, and to be honest really you can even see that where there's a larger concentration of ion filings, it actually does show you that the magnetic field lines are really more dominant in that area as well. Now if we looked at the summary now, the summary basically looks at when two like poles obviously are brought together, they repel, two unlike poles, they will attract. How do we see the magnetic field lines? You simply put ion filings scattered around the magnet, and in order to look at the direction, you use plotting compasses, which is really quite important. Now, this actually sums up the basics of magnets so far. Now in the next section we'll be looking at basically what happens when you actually produce an electromagnet.